welcome. We are going to continue chapter 2 and now we are going to talk about storage medium versus storage device. The storage medium is the actual material object used for storing the data, like a DVD or a CD. The storage device is the item of equipment that handles the use of the medium. For example, the computer cannot read the DVD without the DVD drive. As you can see the pictures below, this is the DVD and this is the DVD drive. DVD is a storage medium while DVD drive is a storage device. Now let's see the first storage medium, which is the hard disk. It is the basic storage medium that the computer uses. It is common for the hard disk in a desktop computer to store 500 gigabytes of data or more. Access to the data on a hard disk is very fast, so you simply click on it and you retrieve the data. The below are pictures of a hard disk. This is when it is closed, and this picture is when we open the hard disk. Now let's look at the inner parts. The data is stored on multiple disks or platters held vertically above each other. Let's take a closer look. These are the platters. The data is saved on the track, which is this yellow circle. And this track is concentric. That means it has the same center, which is right here. And each platter inside the hard disk has several tracks. The cylinder is a collection of tracks that are together. And we said in each platter there are multiple tracks. So for example, if I choose the second track on the first platter and the second track on the second platter and the second track on the third platter, this makes a cylinder. So the cylinder is a collection of tracks on different platters in the same location. And now let's look at the sector, which is a part in the track. And the data is saved on the sector. Let's look at the picture. This is the sector and this is the track at the top of the cylinder. And in the final picture we have the heads. There are several heads and they read the data from the sector. Now we will see it in details. And now this is the read-write head, which transfers the data from the hard disk to the user using the computer. This is a closer look for the head, and this is from when it's in the hard drive. Now we will watch a video together of how the hard disk works. Okay, this is the hard disk. Now the power is on. The hard disk platter is now rotating, and this is the read-write head. Do you see how it's moving? It's reading the data. For example, if we are deleting a folder, look how it moves. And now look how it moves when we want to copy and paste. And always notice how the platters are rotating. The rotation of the platters in this way is called spin. And now we are going to talk about the speed of the hard disk. And now we have some calculations to do for the hard disk. The total storage space on a hard disk is given by the following formula. First, the number of readable sides multiplied by the number of cylinders, which is multiple tracks on different platters in the same location, multiplied by sectors per track, multiplied by bytes per sector. And bytes is the unit that I use to measure the data. And this is the formula in order to calculate the total storage space on a hard disk. So when I say the space is 500 gigabyte, then the output of this formula is 500 gigabyte. Always remember, to reach the correct spot on the disk for reading or writing data, the head must first move to the correct track. The hard disk spins in a constant speed, as we saw in the video. On average, it takes half rotation for the correct byte to reach the head's position. So, the total access time on average is then time for the head to reach the track plus time for a half complete rotation. Now let's move to the next part. Some hard disks have fixed heads and some have moving heads. We already saw the moving heads in the video. Some types of hard disk have a read-write head permanently stationed above each track of the disk. Each surface has many fixed heads instead of single moving head per surface. And in this case, no time needed to reach the correct track. And that means the access is much faster. That means the total access time on average is then only time for a half complete rotation. In the beginning we said time for the head to reach the track plus time for a half complete rotation. But now we only have time for a half complete rotation, so the access is much faster. Let's move to the next point. In order to know the number of cylinders, we have to know the number of tracks on each surface of the disk. Let's look at this hard disk. If the number of tracks is 100, then the number of cylinders is 100. Now let's move to the RAID. The RAID is an abbreviation for a word. Let's look at it. R, redundant, A, array, of, I, inexpensive, D, drive. Redundant array of inexpensive drive. The RAID is a way to save data on more than one hard disk, because if there's a damage in one hard disk, then I will not lose the data and I will get it from another hard disk. So for example, if I save my data on one hard disk and it is damaged, then my data is lost. However, if I use RAID, I will not lose the data because it will be saved on another hard disk. Let's together look at this picture. As you can see, we have 6 hard disks. So, this storage device essentially carries multiple copies of data on different hard disk drives. That means if one fails, the data can still be recovered from the others. And now we reach the final part, which is the external hard disk. It is like a USB. It's external and we connect it to the computer. So let's together look at the picture below. This is the external hard disk and this is the wire that we use to connect it to the computer. So it is exactly like a normal hard disk, but I can carry the data with me wherever I go because it's an external hard disk. So it is built into a separate case. They are robust, small and lightweight. And finally, they can be easily carried and connected to any computer with a USB socket.